Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the creation of circular clickable buttons on a graphics window. This was our application at the end of the last video. In this application, we're using a graphics window to allow us to compile and run this application either using the Windows compiler or the console compiler. At the moment, we're using the console compiler. As you can see, there are two windows on screen. There is a console window on the left and the graphics window on the right. When we left-click somewhere on the graphics window, the coordinates of the click from the left mouse button are shown in our console window. If we right-click, it correctly identifies that the right mouse button has been clicked and the location on the graphics window. We can also pick up the middle button on a mouse if you have one, and we can pick up the scroll wheel moving up or down. Additionally, we have a rectangular clickable button on our graphics window. If we click on that with the left mouse button, it detects a click on that button. And visually on the graphics window, we can see the button depresses for a brief moment in time. We could, of course, add more buttons to this graphics window. However, rather than just adding rectangular or square buttons, I thought it would be interesting to look to see how we could do a circular button. There are a number of ways of achieving this, but we're going to use a very straightforward method initially. But first, we need two images. We're going to have one image showing the button up and one showing the button down. So here is the folder containing our code. And as well as the ClickMe bitmap, we now have two additional bitmaps, a button up and a button down. If we open these bitmaps up, and here we have our button up bitmap. It's a red circular button filled with a gradient fill, with the word Start on the button. If we look at the button down, we will see it's a very similar image, with only subtle differences. A lighter shading at the top of the button and a harder edge to the button itself. So these are the two images we're going to use to depict button up and button down. So let's go and have a look at the code to see how we can achieve this. So the first thing we're going to do is create two new string constants to hold the names of these buttons. So there are our two constants, button up and button down. We could go ahead and put coding into our application to hardcode the handling of each of these buttons, but there is always the possibility that we may want to add more buttons at a later point in time. So I'm going to create a user-defined type to hold the elements of our buttons. And I'm also going to create an array of that user-defined type. So first, let's create the user-defined type. And here is our button data user-defined type. So first we have the X and Y coordinates. This is the X and Y coordinate that the bitmap will occupy on our graphics window. Next we need to know the width and the height of the bitmap. Then following that we have the name and path to our bitmap file. And finally I've got a boolean, a circle variable. If this is true, then the button is going to be treated as circular. If it is false, then we'll treat the button as rectangular or square. Next, we will declare a global array of these user-defined types. This will allow us to put a large number of buttons into this array. But today, we're only going to put two buttons, one to depict button up and one to depict button down. Next, we will go into the PB main function and we will dimension our buttons array. And there we have our redimension command to redimension our array as having two elements of button data, which is our user-defined type. I'm also declaring another variable so we can point at each of the elements of this array. So further down our PB main function is where we set up our graphics window. And below that, we're rendering the rectangular button on the screen. I'm going to leave the code for this as is, and after that's completed, before our redraw command, I'm going to set up our new circular button. So our first task is to populate the elements within our buttons array. And here is the preparation for that. We're setting our pointer to the array to be element number 1. And we're using the prefix command to save a little bit of typing and to make our code look cleaner. So we're setting the x and y coordinates to 300 by 100. We're initially setting the width to be 0, and we're setting the name of our button to be Big Button Up. And we will set the circle variable to be true. This is going to be a circular button. So now that we have populated our global array, how are we going to render the button on screen? To save a bit of code, we're going to create a generic render button routine, passing it the element of the array. And we're going to call this new routine render button, taking its single parameter. So before we create this new routine, we'll populate the global array with the second button, the one that depicts what the button looks like when the button is depressed. So here we have the same construct, but this time looking at element number 2. The location for the top left-hand corner of our bitmap is going to be exactly the same. And we're going to set the width of the second button to be the same as the width as the first button. As you'll note, we hadn't populated the value of the width or the height of the button in our initial population of the first element. I'm going to depend on the code within the render button function to populate these two values. And the last bit are the name of the bitmap which depicts the button being down and also the circle equaling true. And the final command within this section is to redraw the graphic to allow the user to see the buttons. And we're leaving the console window loop as exactly as it was in the previous video. So now we can go and create our render button function. So here is the skeleton of our new function taking its single parameter. This parameter points to the element in the global array of button information. So I'm going to create 4 local variables to allow us to handle this quite cleanly. We will have file, which will be the file handle of the bitmap we're about to open, name, which will be the name of the bitmap, and we also have width and height. So we will first populate the name variable from the global array, trimming it because in the global array, these names are of a fixed length. So this will trim any additional spaces that have been added to the end of our string. Next, we can do a test on the width element. If the width is 0, then the bitmap has not yet been rendered. So at this point, we can then attempt to get the size of the bitmap from the file. We will do this in exactly the same way as we did before in the previous video. We're opening it for binary, and we're using the get command to get the width and the height of the bitmap before closing the file back down once more. Having got those two values, we can then populate our global array, as we have now done. So the final piece of work is to render this bitmap on the graphics window. And as we have all the information held in our global array, we can push that out quite happily using the graphic render bitmap, just as we did in the previous video. So let's try running the application now to see if our first bitmap appears on the screen. And there is our start image. We have a circular button on screen with a graduated red fill. There is, of course, no code in the application yet to allow us to click on the button. The left mouse button is, of course, being detected. So our next task is to work out if the user has actually clicked on the red circular button. The bitmap we have displayed on screen is, of course, rectangular. It just so happens that the colour we picked for the background of our red button matches the colour of our graphics window fill. Therefore, it appears as a circular bitmap when it is in reality a rectangular one. So the approach we're going to take when the user clicks in the vicinity of this button is how far is the location you have clicked on from the centre of the bitmap. And we'll do this by using a very straightforward Pythagoras theorem. So let's go back to the code. So as you'll remember from the previous video, we're using subclassing to detect our mouse buttons. So let's go and have a look at the callback function we created to detect mouse movement and mouse clicks. And here is that function. And in here, we're detecting the left mouse button being pressed. So currently, we have a function called isButtonClick. This is detecting button clicks on our rectangular existing bitmap. So within this function, we're going to create an else condition. If this function returns true, then we know the existing rectangular button has been clicked. If it is not true, then either the user has clicked somewhere on the graphics window, or they may have clicked on our round new button. So let's put an else condition in. And there is our else condition. So we're going to create another new function, isNewButtonClick, passing it as before the x and y coordinates taken from the mouse. And if this returns true, then we're going to print out roundButtonClick. As we did before, there's going to be functionality within this new function to actually render the down button, which will indicate to the user that the button has indeed been clicked. So let's now go and create this new function. And here is the skeleton of our new function taking its two parameters, the x and y coordinates that the mouse has returned. So we're going to create a local variable which will be the pointer to our array. In our global array, we have two button images, button 1 which is up and button 2 which is down. We're working on the assumption that the button is currently up. Therefore, we want to point to the down button. So we're going to create a local variable to allow us to point to the element within our global array which contains both of our buttons. We're working on the assumption that the button currently displayed on screen is the up button. And we want to test to see whether we need to actually depress the button and show the down button bitmap. So we're going to set this value to the value of 2. And we're going to create a number of local variables, a bitmap x and a bitmap y, which is the top left-hand corner of the bitmap, a width and a height. And having obtained that information, we can work out the center of our image, cx and cy. We're going to use a circle variable to return true if the button is a circle and false if it is not. And we're also declaring a new variable called clickZone. If this is true, then the button has been clicked. And the Pythagoras theorem is going to be used to work out the distance between the mouse and the center of our bitmap. So let's start populating some of these variables. So first of all, we'll pick up the x and y coordinates of the top left-hand corner of our bitmap. And then we will pick up the width and the height. And having determined that, we'll then populate the circle variable, which, if true, will tell us that this bitmap is a circle, and if false, it is a rectangle. And then we're going to populate the center x and y coordinates of our image by simply taking the x and y, adding on the width and height, and dividing by 2. So as this function needs to determine whether this is going to be a circle bitmap or a rectangular one, we can test the value of our circle variable. And since this is a circle, we're going to work out the distance to the center from the click the user has made. And this is where Pythagoras theorem comes in. So the distance variable is now populated with the distance between the mouse click and the center of our bitmap. So are we close enough to determine whether the user has clicked on the button? We can do this by seeing if the distance is less than or equal to the width of the bitmap divided by 2. That way we know we're inside the circle. And if that's the case, we can populate the clickZone variable to true, and our whole function now becomes true. Now we can handle if it's a rectangular bitmap. And here we're just using the same logic as we had in the previous video, testing the values of the x and y coordinate with the coordinates of the bitmap itself. So having determined whether we have successfully clicked on the bitmap or not, we can then go ahead and do our graphics attach and render our button. So having determined that click zone is true, we can then use the graphics attach command to direct all our commands for graphics to that singular graphics window. So how do we draw the button? Well, we already have created a function called renderButton. We merely have to call that once more. And the parameter we pass to that is the index of our global array, which currently has the value 2, which is the down button. So now that we have drawn the down button, we now have to wait before we redraw the up button. So I'm going to use a sleep command to wait for 200 milliseconds, and then we can redraw the up button. And we draw the up button by again calling the renderButton command, but this time the parameter we passed will be the value 1, which is the first element in the array. And our final command before we exit this function is to use the graphics redraw command to display our bitmap to the user. So now that we have all that in place, have we done enough to show our bitmap to the user and allow them to click upon it? Let's run the application once more to test this out. And there we have our two buttons. So we can look on the graphics window. If we left click, it's picking up the existing left click quite normally. We can click on the rectangular button and it's detecting button click. And if we click on the round button, it's displaying round button click in our console window. So it is detecting the fact we've clicked on the round button. And visually on screen, we can see the two bitmaps are showing one after the other to indicate that the button has indeed been pushed. If we move to the side of our round button and attempt to click, we'll see although the mouse button is being picked up, the graphic is not being redrawn as a down button push. So the logic within our application appears to be working fine. We could of course go further and use masks for the bitmap, which would allow us more flexibility in the type of button bitmap we could show to the user. However, we may leave that to a later video. So in summary, what we've achieved today is we have created two circular bitmaps, one to depict a button in the up position and one for the button in the down position. We've amended our code to create an array of user-defined types containing all the information on our buttons. We've populated that with the details for the up and the down button. This has allowed us to use a simple Pythagoras theorem to work out the distance between our mouse click and the centre of the bitmap. This allows us the illusion that our button is indeed circular and the user is clicking on it. Hopefully you'll find these techniques useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.